Alright, circular logic number 2. So, in this situation, we have a toy airplane that is being swung in a string in a horizontal circle with a certain radius. The string that it's on is able to hold a maximum tension of 135 newtons. So we're being asked here, what's the maximum speed with which the airplane can travel? If you swing too fast, the string's going to snap, and you don't want that to happen. So, first of all, here, this is kind of an exception to most questions because the most logical question to answer first is the second one. What is supplying the centripetal force? So, since our airplane is stuck on a string, the centripetal force is being provided by the string, which means tension. So, tension provides the centripetal force. So, start there, and then we'll consider some stuff. The stuff being that we've got a mass of 0.38 kilograms. We have a radius of 2.5 meters. Right? Is that a radius? Yeah, radius. The tension in the string can be as much as 135 newtons. And we are asked, what is the maximum speed that the airplane can travel? So, it is important to note that this, when I write that, I mean tension. So I probably shouldn't use capital T because capital T is period. Tension, I'll use, instead for tension, I'll use the force sub T, meaning the force of tension. So force of tension can be as much as 135 newtons, so sadly it's not so easy as just saying, oh, V is 2 pi r divided by T. No, this isn't period, so that won't work. Instead, we'll start with the realization that we made at the end of the problem, which is what supplies the centripetal force. In this case, it's tension. So the tension is equal to the centripetal force. And we'll start with that, and we'll, just work with it for a little bit. Since we know that this is the maximum tension force. If it was less, then the speed would be less. And what we're being asked is, what is the maximum speed? So tension, and again, darn it, instead of using capital T for tension, I should really be using the force due to tension. So the force due to tension is equal to the centripetal force. Ft, we know, great. Centripetal force, we don't, not so great. So F sub T is equal to mass times centripetal acceleration. That's just the definition of centripetal force, which is fine, but notice the V doesn't pop up yet. So it's like, okay, all well and good, but it's not particularly helpful, unless you know the definition of centripetal acceleration. So centripetal acceleration equals V squared divided by the radius. And hey, check it out, we know the radius, and we know the mass, and we know the force due to tension. So let's plug it on in. So force of tension is equal to mass times speed squared divided by the radius. And from there, you know everything. If you like to plug in numbers, plug in numbers. If you prefer to solve it algebraically, do this. So we're trying to get the V by itself. My first step would be to multiply by the radius. Yours is to divide by the mass, that's okay. Alright, we'll cancel here, and we will get the radius times the force due to tension is equal to mass times speed squared. And since our speed squared is multiplied by mass, we'll do the opposite, we'll divide by mass. Mass divided by mass is 1, so it effectively drops out of the equation. What you do to one side, you do to the other. So then we get V squared equals this. But we're not looking for V squared, we're looking for V. So you should take the square root of both sides of the equation. And the speed should be the square root of the radius as the force due to tension divided by the mass. And when you plug in our particular numbers, you find an answer of 29.8 meters per second. By the way, if you're wondering, this is speed. Velocity has a direction, but when you're working with centripetal motion, you're always using speed rather than velocity. Because the velocity is changing so often, it doesn't really make sense to use it. Speed. Oh, I wanted to say, when you're taking the square root, it could be a plus or minus root. since speed is an absolute value, we're just gonna disregard the minus and it'll just be positive. So the speed equals 29.8 meters per second, done.